Okay, now that we have talked about what completing the square is, let's figure out how we're going to use it in order to solve a quadratic equation. So we recognize that we have a quadratic equation here because the highest power of x is squared. Now, we can't factor this down. There's no two things that you can think of that would multiply together to get a 1 that would also combine to get a 4. So that tells us that factoring is not going to work here. Well, our next option is the completing the square. So in order to complete the square, we're going to separate our x's and then leave a blank so that we can create that perfect square trinomial. Our constants we're going to take to the other side, so we can move that over and have just that perfect square trinomial over here on the left. Okay, now in order to create that perfect square trinomial, remember we have to take 1/2 of the middle term, which would be -2, and then we have to square that. So this is what we're adding into both sides. We're going to add 4 to the left and 4 to the right to keep it balanced. Now, because we did this, we took half the middle term and squared it, we have now forced this to be a perfect square trinomial. So it will factor into x and then the halved amount, which was a -2, squared. Always, remember, it always factors into that halved amount there. Equals -1 plus 4 would be 3. And now we can apply the square root property, because in order to undo that square, we would have to take the square root of both sides. So we would now have x minus 2 equals plus or minus the square root of 3. That cannot be broke down any further, so we have to leave it as the square root of 3. Now, we still need x alone, so we need to move the 2 over to the right-hand side to solve for x. So we have x equals, and I'm going to put this in front of the square root to make a little bit less confusion. So that would be a +2 plus or minus the square root of 3. Alright, now when we write this as our solutions, because this is actually two different solutions compactly written as one. This is actually 2 minus the square root of 3, and then also 2 plus the square root of 3. We have two separate answers there for that same problem. Which makes sense if you think about it, because when we factor these problems down, we usually get two answers for quadratics also. Okay, let's try another one pretty quick, see if we can get through this one. This one says m squared equals 8m plus 3. I'm going to move this m's over so that we have m squared minus 8m, and then I'm going to leave a blank so that I can create that perfect square trinomial, and leaving the constant over on the other side. And now we're doing the same thing. We're going to take 1/2 of the middle term, which would be -4, and then we're going to square that. So this is the number that we're adding to both sides to create the perfect square trinomial. Now we force this to be perfect, so it will factor into m and then the halved amount, which was a -4, squared equals 19. And now we can apply the square root property again to undo the square. So we have m minus 4 equals, we can't take the square root of 19 and we can't clean it up any, so we have to leave that as plus or minus the square root of 19. And then to solve for m, we need to move our -4 over to the other side. So m will equal +4 plus or minus the square root of 19. Now, writing out both of our answers, we would have one time the positive and the other time the negative. So 4 plus the square root of 19, and then also 4 minus the square root of 19. Here are our two answers to that quadratic problem.